primarily originally from Google. And we're waiting for Matthew to hit the right button so that he comes over here. Sridhar, if you haven't seen Matthew in a minute, can you go back to the backstage and see if you can help him out? So we've got Matthew Kam, Cody Miller, Miyashin Wang, Vikram Tiwari, and Joyce Millen-Smith, who have done a study looking at what professional software developers need to know to succeed in an age of artificial intelligence. And what's really interesting about this paper is it's one of the first times when they're like, let's rethink all of software development. Let's rethink software engineering in the last 3 years as ChatGPT has become such a major influence on our field and affected even hiring processes and hiring practices and for software engineers. What do software developers really need to know? So they had a really cool study with a paper that's super neat. And the paper is available online on archive.org. And I don't know if Miyashin or Joyce, would you be willing to put the link to the archive version of the paper into the chat? And that way everybody who is here now can take a look while they are listening to the talk. And let's see, we're still waiting for, oh, there we go. Our speaker has made it into the room. Hi, Matthew, welcome.
Wow, thank you. All right, let's figure out how to share the slides now.
Yeah, so people from Google are not used to using Zoom because Google as a company restricts Zoom usage within the company, so it's more rare to play with that.
Okay, how do I share this?
Actually, there will be a.
How did you do it? Oh, that's
So you should have a share button and be able to remember to click the button, the checkbox.
Yes.
Matthew, you're on. You're live. You're live. Yeah, Matthew,
Yes.
you're live.
Okay, that's good to know.
Okay, fantastic. So I have spent a little bit of time before you got here, Matthew, introducing the concept of this talk. What people might not know is that Matthew and I overlapped in graduate school 20-something years ago while we were both at UC Berkeley. And he's gone off to some fun things, including being at Google for the last bunch of years. And let's go back to, I have a set of bots. So what we're going to do is let's do a little round of introductions, and then Matthew and his team will start giving a presentation. The presentation will last about 20 to 25 minutes or so, or 30 minutes. And then we're going to go into a long Q&A session until the end of the hour. And at the Q&A session, please go to your Zoom where there's a Q&A button on the Zoom navbar at the bottom. And if you click on the Q&A button, you should be able to ask a question by typing it in. And that's the best place to put your questions so that we can work with them during the Q&A session. If you also would like to, you can have conversations inside the Zoom chat. We will try to watch that, but it'll be difficult for the speakers to watch that. If there's something super, super urgent, please mention it in the chat or direct message Sridhar Chamalakanda or me. I'm Andrew Bagel, so that we can pay attention to that and solve whatever problem you might be having right away. Let's see. Other than that, if you would like a certificate of attendance for this, please mention that in the Zoom chat, and we will get a list of registrants after the or attendees after the talk is finished, and we will process, basically connect your name from the Zoom chat to your email address and create a certificate of attendance for you and send that to you by email. So just put that in there. And then lastly, we are recording this entire session. And in a few days' time, once we get the recording, we will post that onto YouTube and then post that YouTube link on social media as well as our website for the ACM SIGSOFT website. There's a webinar page, and that's where we post these links. All right, so I think I've covered everything. And now, how about we have Matthew, why don't you introduce yourself, and then we can go around robin to have everybody introduce themselves, and then you can get started.
Okay, great. Thank you, Andrew. So, guys, my name is Matthew Cam. I work at Google as a researcher. I'm a computer scientist by training. I do research these days in both human-computer interaction and education. Maybe Cody, you go next.
Yes. Hello, everyone. My name is Cody. I'm here in the room with Matt. I'm actually a UX designer and strategist working alongside designing developer tools for AI-empowered software developers.
Okay, and there's also Vikram, another co-author with me in the same room.
Hi, everybody. My name is Vikram. I'm a machine learning engineer at ClickUp, where I work on search problems. And I was one of the authors in here as well and helped the team get to this paper. Yeah.
Okay, and maybe Melsin, and then followed by Joyce.
Okay. Well, everyone, I'm Miaoxin. I'm grateful to be here, and I'm a former software engineer and user researcher, and now I'm MBA candidate at Darden School of Business, basically focusing on translating human insights into a responsible business model, like for technology that supports human well-being. And I'll pass the mic to Joyce.
Thank you. I'm Joyce Mallon Smith, and I'm a distinguished scholar with an organization called EDC, Education Development Center, where I lead a body of work on how people develop skill and knowledge in and out of school, then translate that into a productive and rewarding career. Many of my projects now work with defining workplace expertise and translating that into learning models and tools. We were responsible for leading the profile development, so I'm here to answer any questions about that. And welcome, everyone.
Okay, and maybe I can just jump straight to.
Yeah, just go ahead. Go for it.
Okay, great. All right. So yeah, so we have a pretty stellar cast of co-authors here. So our talk today is based on this peer-reviewed paper that Cody presented on the team's behalf. That was last summer during the ACM International Conference on the Foundations of Software Engineering. So that's FSE 2025. Yeah, in the software engineering education track. So the research output from our work actually has two parts to it. So there is this 12-page paper that was peer-reviewed. There's also a 50-page occupational profile that Joyce mentioned that is really the appendix to our paper. So I want to draw the attention of you all to this URL because I'm sure someone's going to ask, where can I find this paper? The 12-page paper, of course, is archived in the ACM Digital Library. But if you want to get the combined PDF that contains both the 12-page paper and the 50-page profile after the paper, which is the appendix, you have to go to this URL at archive.org. The main reason really is that despite the heroic efforts of my co-author, that's like, Joyce, Cody, Melsin, Vikram, and others, we just couldn't clean up the profile in time to get it into the ACM Digital Library as supplementary material for the camera-ready version for the FSC 2025 paper. So it's at archive.org after that deadline. Just highly encourage everyone here in the audience who's interested to just go here to get the 50-page profile. And in this talk later, actually, there will be 2 slides where I will briefly show you guys how to navigate this profile, okay? This profile is actually important because it is a rich source material that has already been used in a number of institutions to drive curricular decisions related to the future of computer science education and how do you ensure that you have a future-ready workforce. So just as 2 examples, right? Since this paper was published at ACM FSC 25, well, there's Andrew, for example, our moderator. He worked with another faculty member at Carnegie Mellon, Austin Henley, to actually co-design a class based on the 50-page profile and to teach it last fall. Okay, so he's the guy who can give you guys practical experiences about what you do with this and how it turned out in the classroom. Broader than just academia, there is this initiative that is called AI Singapore. This is a government-funded initiative in Singapore that also has used our 50-page profile to drive decisions for their education programs, okay? So yeah, just wanted you guys to be aware that, there's this resource here we are making available to the entire community. Okay, let me see. Yes, so of course, need to start with the usual disclaimer that, even though this research was funded by Google, which is my employer, everything that we're presenting here really is based on our professional opinion as researchers, based on the data that we collected. We are not saying anything that reflects an official policy or position of our employers, whether that's Google or Education Development Center or any other organizations. Okay, so just wanted to have that disclaimer.
Hey,
Yeah,
Matthew, I'm just going to
yeah.
poke in for 1 second. We're having a couple of requests to speak a little bit more slowly for those
Oh,
non-native English speakers in the audience.
okay, great. Thanks for the reminder. All right.
Thanks.
So when you think about, why this research is important, you guys would probably be aware if you've been following the news, right, that the popular press is just full of news articles with headlines like this, that basically raise questions about the career relevance of learning to code. Why is it important to code when large language models are already demonstrating this ability to generate code? So that's the context. And we are honored that our research, this paper, was actually cited in a recent op-ed in the New York Times that actually presents a point of view, okay? And basically, just to go straight to the punchline in our paper, the powerful points that we really want to make about the future, and this text here, that's actually in the paper. The perspective is really less about this competition between AI and the human developer. The real risk isn't really about AI displacing developers. Instead, the real risk here is really that developers who are AI enhanced using AI to really take advantage of the productivity benefits that AI provides. They are just in a better position to displace developers who do not keep up by reskilling and upskilling, to just take advantage of the productivity benefits that AI provides, while also making sure that they have the knowledge to safeguard themselves against the risks and the limitations of AI. Okay, so I just want to be very clear about what is our punchline, and then we'll get into the details, okay? Okay, so at the time of writing for our paper, there are already two emerging trends that's coming up. The first trend is that AI-powered tools like GitHub Copilot. When we wrote the paper, tools like Copilot were already widely used by over 1.5 million paid users. The productivity gains are real, depending on how you measure it. So there are research from researchers from places such as Princeton, MIT, University of Pennsylvania, and Microsoft, who found that developers using Copilot actually experience a 26% productivity improvement, just measured in terms of the number of pull requests that they were able to get done. So that's throughput. And if someone's job is only to be writing code, well, we know that that's not true for many people. But if your job is just to write code, this really means that a 5-day work week has become a 4-day work week. Yeah, so that's what the productivity gains really look like. And then, of course, in addition to that, we see that the productivity gains are actually not distributed equally. Some of this early research, such as a McKinsey study, well, it found that the most junior developers can actually take more time, 7 to 10% time longer, to complete tasks when they're using AI tools. So this also suggests that if someone does not have the right prerequisite skills, AI is actually going to hinder productivity. It can also potentially create a risk of de-skilling. De-skilling meaning automating away the very work experiences that junior developers actually need to help them to grow and become more senior. So this basically means that there is a tension going on here. We have productivity benefits on one hand coming from AI tools, but also there is a risk of workforce disruption and de-skilling on the other hand. So there is this need to just define the developer skill sets for the age of generative AI. And that exactly is the backdrop that motivates the research that we are talking about here. So that brings us to our two research questions. The first research question is, well, what exactly are those AI-powered tasks that expert developers who are experts at the cutting edge of using generative AI tools, what are they actually using AI to do to accelerate their work? And then, when you go down from there, right, those AI-powered tasks, what are those corresponding skills and knowledge corresponding to those kinds of AI-powered tasks that are essential for them to leverage AI effectively at their work? So that's our two research questions. The way that we answered this question was to use this research methodology called DACUM. It stands for developing a curriculum. But the key thing here really is the approach. We don't have to get into too much of the details. Joyce here, who's a co-author, can answer any questions people have about DACUM. She's really the expert here that, who led that part of the research and the development of the occupational profile. I think the key thing about DACUM to keep in mind is that this is a very hands-on approach built on this basic principle that, the expert workers are the best people who can tell you about their jobs, which means that in order to actually do the research, we need to be able to recruit a good number of expert developers who can tell us how are they using AI today to really get their jobs done. Okay, yes. So when you think about it, the core of our research was really this DACUM workshop. It took place over 2.5 years. Sorry, 2.5 days. It was led by Joyce and her team. So this is this Education Development Center. It is a research consulting organization that is a powerhouse in both K-16 education as well as workforce development. So this workshop was a very intensive 2.5-day workshop. We recruited 8 panelists from outside of Google, so that we could actually get, their perspective and understand from them how they're using AI. They come from a range of industries, organizations, and organization sizes. Okay, so the
Hey,
key
Matthew,
thing, yeah.
can I just interrupt one more time? There's a bunch of people who are finding that your audio is a little muffled. Do you have any other microphones that you could try to use?
I don't, but maybe I could just move the laptop closer to me. Is that helping you guys?
Um,
Testing, testing.
yes, we're finding some people are saying yes.
Okay, great. I'll just move myself closer to my laptop.
Thank you. I appreciate that.
Okay, yeah, thanks for pointing that out. Okay. Yeah, so basically, when you think of what we were doing, right? Yeah, the DACUM workshop, we were involving expert developers outside of Google because we really wanted to make sure that we are understanding this phenomenon around AI-enhanced software development, not restricting our research with developers who come from Google because they may not be representative of the rest of the industry. And during this workshop, we were collaboratively working with the 8 panelists. So these are the expert informants. So that we could collaboratively identify, what were the things that they were using AI for, what were the skills required. I think 1 or 2 slides later, I do have a few photographs to just show you how it looks like. And of course, there's DACUM, there's Victor from my team, who was one of the participants. So he could also talk about his own experience in that workshop. Okay. So the next thing is, of course, that, besides the workshop, there were other data collection that we did. One thing really was to make sure that, it was so challenging to just do all this data collection in 2.5 days. So we recruited a group of Google software engineers who were also very cutting edge and early adopters of these AI-powered tools themselves, so that we could be doing some early data collection with them around some of the similar questions. We did not share what they told us with the rest of the workshop, but the goal really was just to make sure we were not surprised by what we were learning during the workshop. And after the workshop, we had the same guys together with members in the team like Melsin, just reviewing drafts of the occupational profile that came out of the workshop. The goal here really is to make sure that, once we have this output, which is really important, coming out from the workshop, with other people like myself, who a former CS professor, with industry engineers like Vikram on my right, with former engineers like Melsin, would we be able to understand the profile the way that the original workshop participants intended? And in areas where it was not clear, we really were going back to them to just clarify, making sure that we were all understanding it the way that it was intended. Vikram played a very important role here as a bridge, just bridging what was discussed during the workshop with us, just to make sure that the final draft of the workshop of this occupational profile was reflecting what was intended. Workshop panelists, of course, had this opportunity to review and sign off on the final draft. Okay, so that was the whole validation process we took. Yes, so, okay. I'll just briefly point out on this photograph, this was a group photo. You don't see Cody in the photo because he was a photo pic of the photographer. But you see people like me, Joyce, there's Vikram, there's Beatrice, who's another co-author in it. And I think this is where I hand it off to Vikram to explain the next few slides.
Use this?
Sure.
Nice, awesome. Okay, nice, yeah. So as part of this, tell me if my voice is good or if I'm speaking wide or loud enough. But yeah, as part of this process, the team essentially recruited 21 developers. And this process, like actually, if you are trying to build something that is on the cutting edge, you have to find people who are deeply involved in this process. So the team did a lot of work in trying to find people who can give perspective around this. There were 13 in-house Google experts and 8 panelists that Google looked on, and I was one of those 8 panelists. I found out recruitment criteria afterwards, but it was very strict. They required the developers to have over 6 months of daily usage for Gen AI and report that it was actually having a transformative impact on their work. So this involved actually working with working with the tools every day in, day out, and making sure that you are fully aware of its edges, where it's going, and you can see yourself using it for the future, and then you can be participated in this expert panelist thing. As much as the recruitment effort was extensive, we went from 3,000 developers down to 8 expert panelists. It was still, the demographics were still skewed. This is a big problem across through the industry where there were 7 men and 1 woman in this panel. It's a persistent gender imbalance, especially when we get to the cutting edge of the technologies. We weren't able to come over this, but the panel was still diverse across critical dimensions, such as the range of industries that we were part of, or the company sizes, or even our backgrounds on how we got to the using these technologies for our use cases. This breadth gave us confidence that our findings capture a wide variety of real-world context. And then as we look into this, did it change? Oh, nice. Okay, yeah. So as we went through this process for 2.5 days, we went through, actually, it was like a very fun process. We were all around the table trying to figure out exactly what are the things that we are doing, trying to do our jobs every day, and where is AI actually helping in there, and trying to think about how does that translate into what the future looks like, or where the tools falling short today, and will they still keep falling short there over time. So as part of this process, we uncovered 12 work goals. These are the goals that you are doing as a software developer in your day-to-day job. And with those 12 goals, there's 75 associated tasks that came out that the developers are performing throughout their software development lifecycle. And this is the critical point, software development lifecycle, not just the writing code. It's a heavy focus on it because everybody outside of the industry looks at software engineers as just people who write code, but it's not that. There's a lot of work goals that come into that. And software writing the code is a big part of it, but everything else involves in there as well. So Matthew already mentioned that at the end we have a 50-page profile which we will share. So you please feel free to go through that, and actually do go through that because we took a very painstaking process to identify each one of those tasks and how does it include. But essentially this whole 12 key work goals and 75 tasks all are performed with AI. It includes coding and as initial conceptualization all the way through deployment and maintenance as well. Let's not forget maintenance. Okay, let's go next, which is the software development lifecycle. Let me just see. Okay, here we go. So if you're not familiar with software development lifecycle, essentially it starts somewhere around planning phase. If you are trying to go into a new, totally new project where we have the plan, and then that plan might involve writing some code in there. After you finalize the plan, you meet with your stakeholders, you figure out what you are trying to work upon, then you get to writing the code part. After writing the code, a lot of tools are focused right here, right now, as you might have seen in the industry. Then there's a building part, which sometimes it happens as part of the coding, like all these 3 code build test, but often there's like, of course, CI is failing, and now we are seeing tools which come up and automatically fix your CI issues in here. But I want to focus on just the whole software development lifecycle. And as we went through this, we identified that at each one of these processes, there are AI tools that are helping us. And at that time, like a 1.5 years ago at this point, they were already well advanced, and we were trying to figure out exactly how it's coming into the process. And it's just to note also that it's not a singular process. You don't end with monitor, you come back, and then you find some new things, and then you go back to working on the same thing. So there are 75 tasks that are mapped, and throughout this entire software development lifecycle, you can see examples like the 2B in here, which is acquire the necessary background and technical knowledge. 1F in here, which is minimize complexity by reusing and refactoring code. This is very common if you are not familiar with AI slop as a thing where AI writes so much code that's so hard to reuse that code, or it does not end up reusing a lot of things. It ends up writing new things every time because it's so good at it. that you want to minimize these complexities by reusing these things. Similarly, like if you come out here on the release, plan for contingencies, like what happens, software is essentially a balance of what you should be putting out versus what are the things that you are fine with not putting out and fine with controlling in future. So those are contingencies that you need to look at and plan for those. Similarly, in here, we have transform unstructured data in the monitoring task when you are seeing a lot of user feedback come in and you want to be incorporating those into your new tasks or incorporate those as fixes that you need to do or change the way you are deploying or operating the platform. So these are 75 tasks. They're very exhaustive. And yeah, spend a lot of time to please take a look at that. And some of these are highlighted here, like on some time where we are, some places where we were spending a lot of time because of the time that it takes to write, review, and then collaborate with other people to get to like a good system design and technical decision in here. But all of those are now, you can do a lot of those individually or as a group together into identifying, like explore alternative approaches in here or compare solutions, because the cost of writing these solutions is so cheap that some of these are not only time saving but also lead into better solutions, because you are now not looking at like the local minimum of how good you are, but you can collaborate with the AI to get there. So yeah, we saw a lot of these time savings in here as well. And I'll pass it back on to Matthew.
Okay, so and he's passing back to me because we talked about this 50-page profile. So I just wanted you all to just know how to navigate that. Yeah, and this is a resource we are making available to the community that's working on CS education and workforce development. You can use it as a very practical and usable artifact to drive curriculum and other education decisions. So when you go to the URL at our site to look at that, well, you see three things here. There's really three components in the profile. Of course, it starts with the the cover page. And then right after the cover page, you see some of the skills, knowledge, and attributes that are cross-cutting. Cross-cutting meaning that they apply to all the 75 tasks across all 12 goals that we learn about from the research. The second part is that there's a cover page for each of the 12 goals at work that we saw. People, this was what workshop participants like Vikram voted as the most impacted by AI at their work. So when you take all this stuff, yeah, there's goals such as producing high quality code or improving reliability, covering the whole software development lifecycle that Vikram just walked through. And then there would be a third part, which is a table that under each of these goals. And the next slide is where I'll just briefly show you guys. Yeah, when you look at how the table actually looks like, so you have each individual task. You have concrete examples that just show what the tasks actually mean, okay? And then there's also these details about the human and the AI interaction, so that you actually get a sense of how people are using AI tools at the time of the study to actually accelerate their productivity. And then you have all the corresponding skills and knowledge that's specific to each task. Okay, so that's the way to make sense of the profile. Okay, and now I'm just going to hand it to Melcin to just walk you guys through, what are those skills and knowledge domains that we found in the research.
Okay, cool. Yeah. Now let me briefly walk through some of our high-level findings, and several slides later, Matt will play a video illustrating how the following components tie together and interact with each other in detail. And here, we organize 75 tasks like skill and knowledge into 4 domains using this T-shaped model to visualize the corresponding expertise. And here, the vertical bar represents the depth, and the horizontal bar represents breadth. And what we observed is that in the age of AI, this T-shaped expertise is pressured for expansion in both directions. And yeah, next slide. Yeah. The highlighted vertical bar is the core software engineering. It remains crucial today, and developers, they need that strong proficiency in coding, testing, debugging, and optimization. And essentially, they need to know what that good looks like in order to evaluate, correct, and integrate AI generated output into their existing systems. And as AI automates more of those routine, repetitive tasks, the developer's role shifts toward handling more nuanced, complex tasks that require strong judgment. And this pushes the need for deeper foundations in areas like system design, trade-off analysis, and risk assessment for production readiness. And next slide. Yeah. The left part of this horizontal bar is adjacent software engineering. It's the specialized technical area that sits close to the core development. And depending on the role or company, this might include cybersecurity, data privacy, or industry-specific regulations relevant to the software being built right now. And next slide. The other part of the horizontal bar is adjacent non-software engineering, and this domain is becoming increasingly vital. It includes understanding the world around the code, like from end users, business to market, and even regulatory contexts like GDPR. AI gives these developers more leverage, but to use that leverage effectively, developers need to think more at the higher level of abstraction, like truly understand the whys behind the what. Like for smaller companies, this could mean translating product requirements into business needs. And for larger ones, it's about contextualizing the work to evaluate trade-offs for business value. And next slide. Thank you. And finally, we position this generative AI usage as a meta layer that sits on top of the other three. And this domain extends beyond prompt engineering. It involves a foundational understanding of machine learning, AI's capabilities and limitations. It's also about knowing when to delegate certain tasks to AI, which tools to use, how to critically evaluate outputs, for potential biases or hallucinations and errors, and how to calibrate the interaction to achieve the desired result. Next slide. And putting all this together, like our research shows that to realize the benefit of generative AI, developers need to increase both the depth of their core skills and the breadth of their adjacent knowledge. Like as AI handles more of those routine, repetitive tasks, the developer's role shifts toward more strategic, cross-domain problem solving. And consequently, they're expected to design, architect, and deliver solutions that are technically sound, secure, and aligned with the needs of business. And I'll pass the mic back to Matt.
Okay, thank you, Melsin. So last few slides. So basically, when I show you guys the occupational profile, there's all those tasks, and then there's the skills and knowledge corresponding to each of those tasks. So all of this, when you look across the board, they get aggregated in the form of the T-shape that Melsin just walked you all through. The question really is that how do these T-shape, the skills and knowledge in the T-shape actually come together in practice? So from our research, what we saw was really this seven-step process, or we call that the AI task workflow in the paper. So this is how how and where those four skill domains actually get woven together. The key takeaway to really know is that the AI task workflow shows that the effective use of AI is a process that is way more sophisticated than just knowing how to write a prompt and and just accepting the AI generated output. And instead, this is the diagram that actually shows how active the human role is. The role is not passive at all. It's really about the human having this fluent human control over the AI, leveraging the full range of human expertise. And because a video is worth more than 1,000 words, so instead of me trying to explain anymore, I'm just going to play a brief video. This was something that Cody and Melsin had created with a agency that visualizes this step so you guys could actually see what I mean by that, okay?
As AI becomes increasingly integrated into the developer experience, we have a responsibility to understand exactly how AI is changing the way developers work so that we can build the next generation of tools to complement and enhance their skills. Introducing the AI task workflow, a research-backed framework that unpacks how developers interact with AI across day-to-day tasks. It's an iterative, non-linear, seven-step process. Across the steps, we have identified 4 sets of skills and knowledge developers rely on to complete the workflow. We call these sets domains. The 4 domains are core software engineering, including coding, testing, and design. Adjacent engineering has their strengths and limitations.
Because of time.
With domains
Just
extend
animator.
new levels of developer productivity and innovation. Through the lens of the domains, let's look more closely at the workflow steps. The first step is identify. Developers start a task by seeking the information their AI tools need based on their own AI knowledge and the context of the task, from engineering to business. In step 2, they engage the AI using natural language or code to establish the context, problem statement, and desired result. In step 3, developers evaluate and experiment with the AI-generated artifacts that may include content, designs, code, templates, or diagrams. They cross-check for AI failures and discrepancies against their domain knowledge and expected result. They note the limitations of the AI and areas to improve its output. In step 4, they calibrate the AI tools and their outputs. Specifically, they steer the AI towards their desired result with additional reactions, instructions, and context about the system, product, goals, and potential trade-offs. In step 5, developers tweak and enhance AI-generated artifacts manually based on their knowledge of standards and expectations. In step 6, they finalize their work with up-to-date documentation such as how and why they arrived at the final version of the artifacts. In the final step, developers socialize and influence to obtain buy-in on their decisions when applicable. After all, their work drives stakeholder strategies, business impact, and alignment between and within teams. This workflow helps AI-enhanced developers thrive by informing how future developer tools can be designed to amplify and grow their capabilities, taking human potential to new peaks.
Okay, great. Yes, and I'm trying to move to my concluding slide. Okay. Yeah, so basically, well, what this really means when we think about all this, are you guys seeing it? Yeah, great. Yeah, so what does all our research mean for the future of software development? Well, the implications are significant. First, as you could see, the definition of what it means to be a senior developer is changing because AI is actually handling more of the routine tasks. This frees up developers to spend more time on less routine tasks that involves high-level system design, strategic decision-making that's technical in nature. So what this really means is that the AI-enhanced developer of tomorrow, they need to actually have the skills and professional judgment that we associate with the senior developer of today, which means that the bar of what it means to be a software developer is actually getting raised. And secondly, as you could see from the T-shape, the boundaries between all these different knowledge and skills domain, they are starting to blur. Developers would actually need to become more like a full stack problem solver, not just a full stack developer, need to be able to cross between all these technical and business domains. And third, you see the absolute necessity of continuous learning. AI can actually accelerate learning, but then there's still all this risk about de-skilling, right? Losing all this fundamental understanding that, that can happen if we don't actually cultivate deep and foundational knowledge. So the call to action that we have for all of you here is that how do we think about equipping developers with the skills and knowledge needed to succeed in the age of generative AI? And if we have gotten some of you interested to read our paper or the profile further, I think that would be what we have set out to achieve in this talk. So thank you so much.
All right, thank you very, very much, Matthew, and everyone else. Matthew, Shan, Joyce, Vikram, Cody. Very, very cool talk. We've got lots and lots and lots of questions on the Q&A. And through the Zoom as well, I've been copying out some questions as well. I kind of want to start with one question that has been on my mind, and it kind of came up through here, which is if the new baseline for what kind of developer we need is essentially a senior developer who also has the skills to use AI, how do we get junior developers or even college graduates or even people in college to become senior when that used to require 10 years in industry before they would be even ever considered to be that advanced. So is that allowed to be the new low bar?
I can try taking that one. So I feel like this is the same as when originally, like I'm trying to go like 50 years or some back, like 90s, when typing was the hard skill that you needed to get into computing because typing was so hard, people didn't know how to type. And then of course some math and some problem solving. I think that part hasn't changed on like there you still need to do and use your tools before you get in. I think the bar is definitely getting raised and raised on how you solve problems. I think the way we think about software engineering will also need to change in a sense that think of like way back when we used to look at bytecode and try to compare that to figure out is it actually working. But today that verifiability has gone out of question, and we have machines which do the verifiability, where we write the code in high level programming languages, and the code is verified by the compiler and it optimizes the code and everything else underneath it. Now we are trying to see another layer coming in where we don't even write the code in high level languages. We just use our natural language to write this code, or starting to use natural language to write this code. So the verifying level will also need to change to get this point of, is it actually working the way it's supposed to work? Similarly, the thing that we are like very proud of how modularized my code is, or how scalable my code is, those things will start changing into the taste of the app that I'm building, or the taste of the software, or how well it scales versus how often do you have to go back and redo the thing. And maybe the redoing cost is very low, but sometimes that cost is something that you have to think beforehand versus in the flow. So I think, yes, to go back to the question, I think the bar is getting high. It is going to stay there. And I think it's changing. It sucks right now for everybody who's a student, but I feel like it was bound to happen. That computer science as an industry has been stuck on this level for a while, and I love to keep seeing it like continuous learning, continuous education in here. It's going to play a big and bigger role into this.
Thank you. I appreciate that answer, Vikram. I'm going to roll that over into a follow-up question, specifically looking at you guys at Google. How exactly have you changed your interview practices to find such more AI-enhanced software developers that you're requesting or suggesting should be made available as the candidate pool?
Yeah, well, actually, I don't know because none of us are actually in the business of interviewing our engineering candidate pool, but you have a perspective.
Yeah, I can add a little bit, Andrew. I mean, we can't speak too directly to our interviewing practices, so I just want to make that clear.
Yep.
But if I take the learnings from this research to this, I can say that the idea of having more breadth and depth and cross-domain knowledge is a critical component to be a successful engineer. I can confidently say that's becoming more and more important. So you need to have deep knowledge in software engineering, but also deep knowledge in adjacent domains like cybersecurity or more business and user intent. Because as more you are orchestrating agents or AI systems to do work on your behalf, it needs to be aligned with the user and business needs. And so having a clear understanding of the work around software engineering, I can see as an important skill that's emerging. And I would predict that's important to our hiring practices.
All right, great. I'm going to start going through the questions in the Zoom Q&A chat and see if we can make our way through some of those. Ira asks, my experience as a software engineer is largely with enhancing large applications like millions of lines of code. And much of the work requires some understanding of how the code is organized and how to find places to start making changes. How does Gen AI help here?
Well, so people so that's actually a good point, right? Because one thing we also found in our research is, if you look at the T-shape, part of it is really having that understanding of the code base in order to use AI effectively. So you have folks who are using AI more to help them explain what the code actually does. So that's one way in which AI gets used. I would just point out that that's a very important distinction, because just explaining what the some part of the code base does is not really the same as explaining how it does it. and to engineers, I think that distinction is still important, because you still need to not just the what, but also the how, so that you could reproduce some of the behaviors yourself to get the the kind of behaviors you need in your own code. Yeah, but that's one of the things we are seeing.
Yeah, it's interesting. We've also, so I'm at Carnegie Mellon, and I've taught a course that was inspired by this paper. And we asked our students here is a program we found on GitHub. We want you to add a feature to it. We also want you to document it and explain how it works. And when we asked the students, they went and used Gen AI to do that. And then when we asked them questions about how does this part work, as a computer scientist who can read code and figure out how it works, they had no clue, and their documentation that they generated was not helpful, because they didn't know what they didn't know. They didn't know what they needed to know. And it seemed like just in time kind of questions of the code base are much more fruitful and useful uses of the AI than questions of general information for everybody.
Yeah, and it's so interesting that you're sharing that experience, because it feels like that it goes back to, computer science 101, right? Algorithms, and just being able to explain what the algorithm exactly is doing.
Mm-hmm. Let's see. So we have another question, which is interesting, from Kapil. What are your views on vibe coding? So where the whole writing of the code is taken over by agents. Do you see this as do you see the future as basically where software engineers have a different job? Their job is just monitor the agents as they work on bugs or new code, versus actually doing any of that coding themselves.
Okay, I don't know if Cody or Vikram want to chime in on this question, because Cody has actually been actively working on agentic tools for developers, but Vikram also actually created a few backup slides for this presentation, and I feel that this is touching on some of those. So who wants to
I can start, and then I'll let Cody talk a little bit more. So I think what we are seeing right now is we are moving away from just coding into analysis. Nice. Okay. So yes, definitely coding, and coding is becoming less and less of a job, and we are going away from vibe coding into vibe engineering. And as one of the things that we mentioned in this paper, the coding is one part of the job. It seems like people who are not software developers, for them, coding is the whole job. But as you go into this, the whole process is really huge, and there's a lot of tasks that involve into this. But yes, coding part is becoming more and more common, and it's so common that these days, yes, you rarely write any code. You look at the code, you realize what needs to be done, where it needs to be done, and then you just ask a model. It's to a point where this is a post from Jana, who's a principal engineer at Google. She and her team have been working on agent orchestration tool at Google for a whole year. They try to come up with different teams, different opinions, trying to come up with a problem statement that they can build a tool for this agent orchestration. Versus during the holidays, she tried to use Cloud Code for this, and she was able to complete the problem to a good degree. She's an expert in this tool. She has worked on distributed systems for a while, so she can tell the output of the tool is really good. She built all of that within an hour using Cloud Code. So yes, the writing code part and even assimilation of the problem to get to a solution is going to get away and will be very abstracted away from the users. And you will focus a lot more on actually building and actually verifying the problem. And that's where comes in this verifiers law, where the problems that are verifiable, like math, chess, code, these will become solved, or these are already to a point where we're calling it solved. It's mostly optimization problem, where they will start to get more and more solved, because as long as you can verify that a problem is fixed or not fixed, you can train a model to make it better and better. And as Andrew was talking about earlier, where the questions which are just in time, it's helpful, but it doesn't understand why it's doing something. Those are like kind of subjective, like why did you go into this approach of using it in a different way? Some of those are fairly objective because the system wants to scale, system needs to scale. But some of those, like poetry or some subjective truth, those are harder to verify, and those will still remain the frontier, or at least right now they are the frontier. I don't know when they will get solved, but that is the asymmetry of verification, and that's why we see that some tasks like coding and math are becoming so much easier, and nobody expected us to go so fast on some of these tasks, but it's becoming better and better. Versus the writing the the blog post for you is still a taste thing, is still a verification thing where it takes some time. And if you want to look deeper into that, this is how you think about it, where there's an objective truth. How long does it take to confirm that the objective is correct? Can we scale it up or no? No. Is it a low noise? Is the feedback that you're getting is good? And can you do it continuously? And if you can think of any task, coding is one of those, but if you can think of any task that you can fit into this framework, it will get automated. It will get to a point where the AI and these LLMs will start to make it better. There might be problems where we don't have a scalable way to do some of these things. Like robotics is at a state where it's very hard to scale that up right now to do millions of attempts, because these are machines. They take a lot of time to they break down. But these are things that will happen, and we will get to a point where this will start to get more automated. I'll let Cody.
Well, Cody, you have a perspective? No? Yeah, but Cody has been working on the agentic stuff. Okay.
I'm just gonna go back to this slide.
That's fine.
Yeah, actually, I would have another question. So there was a post from Boris Cherny, who's the creator of Claude, a couple days ago on X, that described the way he uses parallel agentic AIs in multiple windows going at the same time to do coding for him, and all he does is just flip between the tabs to figure out what questions do they have, and for him to say yes to or continue or respond to. Is that, do you view that as a cool way to work? Is that a weird way to work? Is that things we are trained to do as software engineers? I'm Gen X, so was trained a very long time ago in software engineering. Is that something we can learn?
Yeah, I wonder if we can have a perspective, because I like how, when that post was made, right, I think he was very clear that this is his workflow.
Yeah.
May not apply to everybody else.
Yeah, I think we are realizing that everybody has a little bit different workflow, and everybody trusts the models in a different way. One thing I like to do is look at this is the current way we are working. It's like it is a industry standard on the way we work and release software to everybody. And there are human reviews that come into this process. There are tests that we write. There are load tests that we run on like production. There are A/B testing that we do. So there's a lot of process in here that is very manual, that involves a lot of inbuilt practices, and it is a lot of things that are changing. And there's still a lot of people don't trust these models, and with good reasons. There's not always they're good or not always accurate. So there is definitely that problem, but I think the way I'm starting to think about it is all of the restrictions are now at the point of review speed and verifiability. So what you should try to figure out is how can you reduce or remove those bottlenecks from your system? It could be a human bottleneck, the way the Boris is doing, where he wants to go take a look at the final completion for all these parallel agents. It's not that they can't really collaborate together and merge their Git changes, or they can't continue working on the task. It is because he wants to make sure that the thing that he's putting out as a developer, we take pride in our work. So everything that we try to put out, we try to stamp it with, yes, I reviewed it, I looked at it. We as a team have reviewed, or we as a team stand behind this software. And that is the part that is still a biggest bottleneck. I'm hoping that it will get solved over time more and more. And then this becomes an easier pipeline. Cody and I were talking about earlier about ephemeral software, where you don't have to even think about what the software is, and it gets generated for the user on the fly. And that's like a future that we look into. We don't know if we'll get there, when we'll get there. It's a long horizon thing. But yeah, those are the real things from my side as I see about it. Yeah.
Yeah, what's interesting about that, I feel like, is there's not a lot of support from the tools yet to do this kind of review. And especially when the AI generates hundreds of files in some kind of new React program or something, that's just too much for a human to just be like, yeah, it seems like it's good or not. But if there were tools that could take you through that process to help you scaffold that review so that you could be sure that the AI was, following a reasonable process or a reasonable path. That's kind of what we do with people, right? We don't just say looks good to our junior developer. We have them take us through some aspect of what they designed in order to believe that we trust them, that they're doing it reasonably. And yes, we believe that they're going to get the coding right so that it compiles and that it passes the test cases because we trust them for that. And that's what we trust the AI to do. But knowing how to do it and being able to explain that to another person is really the signal that says, yes, you can go off on your own and I believe you'll get this thing done.
Yeah, Andrew,
Yeah.
I just want to add, I think it's an exciting space to be designing developer tools because there are a lot of those challenges. And I just wanted to plug, there was a recent product launch for Google, actually. I work at Google, but also I'm excited about this product regardless, is anti-gravity. And they're starting to introduce new paradigms of tooling, like a new mission control hub to orchestrate agents both synchronously and asynchronously and help humans start to manage the scale of orchestrating many jobs, many tasks at once. And I think it's an interesting space right now to think about how we can support our developers to orchestrate these larger systems. Are the design of our tools supporting that? And then helping humans with the knowledge that they have kind of steer and coordinate these agents in reliable ways. So I think it's a really interesting time just for developer tooling. All
right, thanks. We have another question actually from Sridhar, one of our moderators. Sridhar, do you want to unmute and ask your
Yeah,
question?
yes. Quickly, so I think, I'm just curious, what is your, the Google teams, like Matthew and others, view on the use of, or on the emergence of natural language. Now, given that so much is happening, how much of, say, for example, non-native speakers of English, or how do you see the proliferation of natural languages in this entire thing? And do you think people, the new software engineers or developers in the AI era, can they use natural language to sort of produce end-to-end software? What's your take on this?
Okay, and again, because people always ask what is Google's view, I'll just go back to my disclaimer and say this is my personal opinion. It's kind of interesting actually, and maybe you guys or some people in the audience might think I'm old school, okay? Because there's of course natural language, right, which is I think more natural for humans as users. But the thing is that natural language also is not really perfect, and that's why there's technical language that gives you the kind of precision for talking about certain things, right? And then there are some of these old ideas in software engineering, like spec-driven development, for example. Yeah, because you need to get the granularity right to talk about what kind of specifications and behaviors you want. Yeah, so I just don't feel that natural language is perfect for just capturing that. But if that gives developers a good head start in their workflow, I think that's great. You can look at other disciplines too, right? It's like, economics, for example. There's just, sometimes the way to understand an economics paper is not to read the natural language, just read the mathematical equations, because you need to understand what the models are really about, what are the variables and all that stuff.
Can I add? So I'll just add one more thing in here is I think natural language is very popular right now because that's how we as humans think about passing the instructions. But there's this thing coming up, Alpha Evolve, if people haven't seen the Alpha Evolve paper, where the machine looks at this, LLM looks at the incoming stream of data, which is essentially telemetry data in one of the examples where they try to optimize the essentially a whole data center. It's the telemetry of the data that's coming in. It looks at the data, it tries to write the programs for optimizing all of that, for analyzing the data, optimizing the whole workflow in there, and then outputs an algorithm or a new system of doing management of this whole system. Like at this point, the natural language is off the question. The only reason we think of natural language is because that's how we think of that. We know what's best and we provide the feedback to the machine. But think of you build a software which can auto-optimize itself. We talked about self-driving cars, where the cars themselves, based upon the feedback, can start optimizing themselves. I think we're getting to a point where natural language is going to be the worst way to communicate your intent. The models will learn from your behaviors and your actions. And we talk about ephemeral software where you go visit a website and you want to purchase. Why am I looking at 50 different things versus just a purchase button? I just want to see the buy button as the highlighted. So I think that will happen way faster than we think it will, but yes.
All right, we are at time. I want to thank our speakers. Thank you so much for this really fascinating talk and Q&A session. This is definitely a topic that's going to engage software engineers for the next few years, at least until the machines fully take over and we fully have a job. But I want to say for everybody out there, thank you for attending. Our talk is being recorded right now, and the recording will be made available on YouTube sometime next week. If you want a certificate of attendance, you have been sending messages in the chat. We will process those sometime throughout next week. There's a lot of you, so we'll get to that. And then for anyone who is interested, I think I've seen several requests to share the slides, to share the video that was on those slides, and to potentially also reshare the paper. And so we'll make sure that the ACM SIGSOFT webinar webpage and social media will have those links in there so that you can find them afterwards. But again, thank you very, very much for coming. I appreciate your time. And we will stay tuned for future ACM SIGSOFT talks. If you have ideas for talks, things you'd like to hear about, please send some email to anybody at the ACM or to SIGSOFT really that you can find, including myself, Sridhar, and Marcia Chechik, our chair, because we are always interested to have really fun talks and panels and presentations for everybody. But all right, thank you very much. And for everybody who is a speaker in the talk, I'm going to end the webinar itself and push you back into the backstage, and then we can just debrief there.
Okay, and thank you everyone for just having us here. There's Vikram, and
Thanks,
then there's Cody.
Thanks, everyone.
Okay.
All right, thank you.
Okay, thank you again.